Hey 8th graders, I am excited for us to move on to solving systems of equations by elimination. We ended last week with doing this problem that it was a lot of work because we had to get one of the variables by itself and neither one was very nice, and then we had a fraction. I mean, it just took a lot of work. And so what we're going to learn today is how to solve for these variables using elimination. Okay, so it says the system below would not be too fun to solve by substitution. Follow along to learn a new trick. So it's not very fun, just like we had in the last problem. The first thing you had to do was get one of the variables by itself. Then you had to put it in. We had fractions. It does work out. So for example, when I solve this, divide both sides by 15, x is 2. Then you put 2 back in, and if you'd multiply this, you'd end up having a 12 over 5. So this ends up being a 12 fifths, negative 12 fifths plus 17 fifths. Well, 12 and 17, when you find the difference, you get 5 over 5, which is 1. So your solution is 2, 1. Okay, so they did most of the work for us. I'm going to show you an easier way. So with elimination, you have to have both of your equations in standard form. Now, what the cool thing is that if you can cancel out the x terms or the y terms, you basically treat this like a big problem. So for example, when I look at this, I know that a positive 5y and a negative 5y, they cancel, okay? And this is new to us. So 6x and 9x, that gives us 15x. 17 and 13 give us 30. And then I would divide both sides. And I would get x equals 2. Okay? Then you just go put that 2 back into one of your original equations and solve for y. So for example, this would be 6 times 2. I'm just using that top equation. Plus 5y equals 17. So this would be 12 plus 5y equals 17 minus a 12 from both sides. 5y equals 5. Divide both sides by 5. Y equals 1. So your answer is the same, but it took much less work. Okay? So the elimination method. You have to create opposite like terms, okay? Then you add or combine the equations together, thus eliminating one of the variable terms. Solve the one-step equation, use the variable you know to find the one you don't. So we'll go through some practice. So these first ones here, the 2x and the negative 2x and the positive 2x, these are our opposite like terms. So I can take this equation and these just would cancel. Then I have 1y plus 8y, which gives me 9y. 14 plus 22 is 36. Then I would divide both sides by 9. That cancels. I get y equals 4. Now I choose to put this into one of the equations. It doesn't really matter which one. I'm picking the top one just because y is kind of by itself. So in my brain, that one's the easiest one to put the y in for. So then what would I do? It would move the 4 to the other side. Negative 2x equals 10. Divide both sides by a negative 2. X equals negative 5. So your answer is negative 5, 4. Okay. Next problem. Now, the x's match and the y's match, the numbers do, but they have to be, one has to be positive, one has to be negative. So these ones are going to be our matching variables. So I'm going to add this. Remember, if there's a negative there, there's a negative 1. So negative 1 plus negative 1 gives us negative 2x. 2x plus negative 2x cancel. Negative 13 and positive 11 give us a negative 2. Then I would divide both sides by -2. X equals 1. Okay, now you get to go put this back into either equation. Doesn't matter which one. I'm just going to go with the top one. So -x plus 2y equals -13. So this is going to read -1 plus 2y equals -13. Solving it, add that 1 to both sides. 2y equals -12. Divide by 2, divide by 2. My y equals -6. So 1, -6 would be our solution. Okay. So let's go to the other side, a few more problems. So it says the next two systems do not have opposite like terms. Let's see what we can do. So what you're going to do is you are going to get opposite like terms. So the first thing that I look for is matching coefficients. Coefficients are those numbers in front of the variable. So if I look here, look at these are matching, they're just not opposites. So I get to choose to make one of them a negative. Now sometimes I look ahead and I'm like, oh, which one would be better to change the signs on? And in this particular one, the equations are exactly the same, so it doesn't really matter. But let's jump ahead. We're not going to do this problem yet, but let's look at it. So here I have matching 8y's. They're both negative, okay? Now, I think what I would do on this one is I would change the bottom. I'm going to multiply this one through by a -1, because then I'm going to get rid of that -3x. On this one, it doesn't really matter. So let's just take the bottom equation maybe. So I'm going to multiply that bottom equation through by -1. So the top equation stays the same. The bottom equation, -1, and you're kind of like distributing this to all three terms. This gives you -6x plus 7y, because it changes to a positive, equals -18. Now I'm going to add them together. So now we have our matching opposite terms. +7, -6 is a 1y equals 24 minus 18 is going to give us that 6. Divide by 1, y equals 6. Then you just go plop that into one of your original equations and solve. Doesn't matter which one. I'll just do the top one. Okay, so if I put a y in for y, 6x minus 6 times 6 equals 24. 6x minus 36 equals 24. I'm going to add that 36 to both sides. 6x equals 60. And then divide by 6. And I get x equals 10. So my answer is 10, 6. Okay, on the other side we kind of talked about it. I'm going to change my bottom equation. So my top equation stays the same. My bottom equation, distribute this into every term, and I get 3x, and then this is going to be plus 8y equals -8. So in this case, my matching are right here. We're going to add these. So 2x and 3x gives us 5x. My 8y's cancel, and 8 plus a -8 is 0. Now, you have to remember that it's okay to get 0 for an answer. That just means it's on one of the axes. Okay, so there's 0. Now if I put 0 into one of my equations, like I said, it doesn't matter which one. I tend to avoid negatives, so I'm going to go with the top one. I know I'm not avoiding all my negatives, but so 0 is going to go in for x. So 2 times 0 minus 8y equals 8. I get -8y equals 8. Divide by -8. Y equals -1. So your solution is 0, -1. Now at any time, if you want to check your answers, you just plop this ordered pair into both equations, and it has to make both true in order to be a solution. Okay, the next two are going to be those special cases. So what happens, if you look here, when you go, you've got matching opposite coefficients on both terms. So what happens is that the x's cancel, then the y's cancel, and then the 6's cancel. So you end up with like 0 equals 0. So 0 equals 0. Is this true? So is it true? Yes. So what that means is it means that we have infinitely many solutions. If you solve these equations for y, the lines are actually the same. Okay? So, you just don't always see it when they're in standard form. Okay, then our next one, you're going to try to get matching opposite coefficients. So you've got to multiply through by a -1 on one of them, the top or the bottom. So this gives me -6x minus 7y equals -18. The bottom then is just going to stay the same. And what happens when you go to solve these? This cancels out, you end up with 0 equals, and this gives you a +5. Is this true? No. So what does that mean? That this is a no solution. Okay, these lines are parallel. If you would solve them, they would have the same slope. Okay, last situation. Let's solve the word problem below by creating and solving systems of equations, or solving systems of equations by elimination. Now, I know you guys aren't a huge fan of these word problems, but you're getting better. I had a few people email me to test out their equations. Please do. If you're getting stuck on something, definitely shoot me an email. So it says, Kayla sells candy bars and cans of soda. So I mentioned that one of the first things I do is make one of the variables candy bars, X, and one of them, Y. She charges $3 for candy bars. So if I bought 2 candy bars, I would take 2 times 3 and $1 for a soda. She sold 70 items altogether and earned $100. How much candy did she sell and how much soda? So we know 2 things. We know the total items that she sold, and we know the total amount that she earned. So if I sold X candy bars plus Y cans of soda, that would equal 70 items. So that's how I get my first equation. My second equation, every candy bar costs $3. So 3 times the candy bars plus 1 times the cans of soda equals the total amount that she made, which was $100. Now, I know that you could go back and you could use substitution in this. It would not be very difficult, but why not use elimination if we can? So in this case, look at, I have both of these. Technically, there's a 1 here, so they match. So I can just multiply through by a negative, and this gives us -x minus 1y equals -70. The bottom equation remains the same. We don't change it. Okay, so -x, we're going to add these. -x and 3x gives us 2x. The y's cancel, which is what we want. And then here we get 30. Divide both sides by 2. X equals 15. What is X? X is candy bars. I'm just going to put that down right here. So if we sold 15 candy bars, we sold 70 items total. What does that leave us? So you guys can think about this. You can go back to this equation if you want. 15 plus y equals 70. Then minus 15 from both sides. A lot of you probably don't even need to do that second step. So how many candy bars or how many cans of soda? There were 55 cans of soda. So that's the word problem. So what I'm going to have you guys do is the next page, just a front and back, 9 problems. We're going to take this a step further next week, But don't worry about that for now. Just work on the following page of homework. Hope you guys are doing great. Enjoy today. It's supposed to be beautiful.